The basic concepts from this tutorial are: describe the motion of an object with constant velocity. Describe the motion of an object with a constant acceleration. Use a variety of kinematics equations to solve assorted motion problems. Almost everything we witness in our everyday lives involves motion. Notice how the motions of the objects differ. Kinematics, the mathematical description of motion without any reference to the cause. The cause of this motion will be described in a later tutorial. Although vectors will be fully explained in a later tutorial, a brief introduction is needed here. A vector is a quantity that has magnitude or size and direction, while a scalar is a quantity that has only magnitude or size. Examples of vectors would be velocity, displacement, and acceleration. They all have a direction. While examples of scalars would be speed, distance, temperature, and mass. They have no direction. Velocity and speed are similar terms. They're often used interchangeably. However, there is a slight difference. Speed is a scalar. This means it has no direction. Velocity is a vector. It has a size or magnitude and a direction. Imagine a toy train is moving along the tracks at a constant and steady rate. There is no slowing or speeding in its motion. Notice how the train moves at that same rate. This motion represents a constant velocity. The velocity of this train can be found with the following formula. Velocity equals distance divided by time. Velocity would typically be in meters per second. Distance would typically be in meters. And the time would typically be in seconds. Other units can be used, but these are the typical metric units. Sometimes the previous formula is written as v bar equals total distance divided by total time. The bar above the v means average. If an object moves with a constant velocity, the average velocity is the same value. So, if an object changes its velocity, this formula may be more useful. Here's an example. If sunlight takes about 8 minutes to go from the sun to the Earth, how far away from the sun is the Earth? An important hint, light travels at 186,000 miles per second. For this problem, use our formula, velocity equals distance divided by time. However, we might need to rearrange the formula for the variable we're looking for, distance in this case. Substitute the time that's given and the velocity. Note, 480 seconds is simply 8 minutes converted into seconds. Notice how the units cancel out. When you multiply, you're left with 8.9 times 10 to the 7th miles. Instantaneous velocity, the speed of an object at any particular instant in time. The average speed and instantaneous speed may not necessarily be the same. For example, a car that gradually speeds up more and more has an instantaneous speed that's always changing. If the police monitor your speed with a radar gun, are they checking your instantaneous speed or your average speed? They're looking at your instantaneous speed. They would be interested in noticing if you exceed the speed limit at any particular point in time as they monitor you with the radar gun.